All right, thank you everybody for coming. Let's go ahead and get started. So today I want to talk about tuning Tableau Server, really with an emphasis on performance best practices. So before we get started, I want to do some quick introductions. First, a little about myself. As on the previous slide, you saw my name is Jonathan Varkovitsky. I'm a product manager here at Tableau, and I've been at Tableau for 5.5 years now, so quite some time. When I first joined the company, I was heading up the performance test team along with one other engineer. After that, I moved into a space where I was looking at performance issues on enterprise customer deployments, trying to see what was going on, how we could make things better. And then in this year, I moved into the product manager role, overseeing all customer defects that are coming into development and needing help and code changes. So since we're in Vegas, and I've got a really fun, long last name that I'm sure everybody remembers how to spell without looking at the app, let's play a quick game. Everyone's favorite Vegas game. Everyone ready? Scrabble. That's what we all came here to play, right? So does anyone here play Scrabble? Anyone? Some hands? Okay, a few people, not bad. So I was asked, how many points could I score using my name in Scrabble? Setting aside the fact it is a proper noun and not a valid name. So I played around with some tiles and I found out apparently my name is worth about 32 points, which it's not bad. But I started thinking, how could I make it better? How could I really score more and more points? Really utilize the board to my advantage? So real quick, for those people who said they were Scrabble players, who thinks that maybe we could get 50 points? Maybe we could get 100 if we really played our cards right? I think I see 2 hands for that. What about 400 points? Anybody? 1. Absolutely. All right. What about 1,000 points? No. Okay. Turns out, if I play my cards right, I can get 433 points utilizing a nice double letter score on K, 2 triple word scores, and a bingo, because that's a long name, and I'm using all of my tiles to spell this one out. As I mentioned, not a valid word. Turns out the most points you could score is about 362 on Quixotry, meaning exceedingly idealistic, which is how I feel about ever getting that word while playing Scrabble. So really quick, I want to learn about who you are, my audience, who's come here today. So for this activity, we're going to go down a list of questions. So let's all put our hands up, because in the beginning, almost everything should apply to us, and then put your hand down as the following thing no longer applies to you. Do you use Tableau Server? I think almost every hand stayed up. Excellent, because we're here to talk about Tableau Server. Have you ever experienced a performance problem on Tableau Server? All right, a few hands went down. That's good. Have you ever contacted Tableau support to work on that issue? I've seen some hands go down. I'm glad to see we still have some people who are reaching out. We're trying to fix the problem. Now we're going to get into some really narrowing down features that there'll be probably very few hands up. Have I ever spoken to you on the phone? Maybe. And then the last question, have I been in your office? No. So we'll say last year I did get a hand for that one, which was very exciting, from a customer that I had visited. So it's very nice to meet all of you, and let's go ahead and dive in, and let's start with how to tell if you have a performance problem, because this is the beginning of our journey. And usually it comes as one of our users is coming to us and saying, I have this problem. Maybe it's my viz, maybe it's logging in. So you're kind of like a doctor and they're a patient telling you some of their symptoms. So let's quickly go over some of those common symptoms, and then I'm going to go over some tools and then changes that we can make based on what we see from those tools to improve their experience. So in the beginning, a customer might say a certain workbook or project is underperforming. They use things all across the server, but boy, it's just that whole sales project has some issues. Or user reports the system as a whole is slow. So they're logging in, even that experience is slow. That could tell us something different about what's going on under the hood and what we need to tweak. A number of workbooks that share a common data source could be having the problem. And so this can tell us maybe we want to look at our query performance or what's going on in the data source, or how could we make that experience faster. Now, more on the administrative side, we might see processes restarting frequently in the background. And you may notice this yourself, or I'll go over how some of our tools allow you to actually see when Tableau is self-healing by calling processes that are using up too much resources. And then finally, you may have a third-party application that is monitoring your CPU usage, your memory, all sorts of things, and it's alerting you or your IT team automatically. A lot of our customers have that in place, so that's also something we want to look at. So now, we've heard from our users, from our patients, that they're having a problem, and now we want to pinpoint what that problem is before we can treat it. So I'm going to go through kind of a handful of tools. I'm going to start with kind of the most basic, working my way down through more complex tools, and I'm going to include a mix of tools that are provided for free by the operating system, and then some tools that we created here at Tableau that we've shared with you Some of those are open source tools, and others are actually integrated into the product. All right. So the tools we're going to go through, and again, in roughly the order of complexity, is Task Manager, our trusty friend. Then we're going to go down to Perfmon. And then after that, I want to go into Tabmon, which is short for Tableau Monitor and was created internally by a team very close to mine at Tableau. Then I'm going to talk a little bit about the Tableau Performance Recorder. And unlike Tabmon, that is an open source tool, the Performance Recorder is integrated into the product, and you can use it on any of our platforms. And then finally, we're going to talk about, frankly, my favorite tool for doing log analysis with our tool LogShark. And this is an open source tool that is available to all of you to use, and you can even contribute if you so choose. So first, let's jump into Task Manager. Most of us are probably familiar with this. Most of us don't think to look at it when we're administrating an enterprise-level tool. But it's very useful if you want a snapshot for what's going on at that very instant. So in this case, I did a tab admin restart. So you can see my CPU is pegged, and I'm restarting those processes. Kind of expected while the process is still coming up. And you can actually see the dip in memory from when tab admin stop was executed under the hood and when tab admin start ran. So you can see there's a little bit of gap there. So it's kind of nice. You can see what's happening, but it's only a limited time window. Also, you can switch to the process menu, which you also may be familiar with, and see which resource is using the most CPU or memory, or sort by name if you're looking to see how much is, say, VizQL using or backgrounder. So you could do that here. It's nice. The one thing that is kind of the limitations, as I said, it is only instantaneous view, and it only runs on the machine you're looking at. So you could remote, say, to your primary, Control-Alt-Delete, Control-Shift-Escape if you're remoting, and see this window, and you can see what's going on. You can take a screenshot like I did here, but it's not good for long-term storage or sharing the data. One interesting thing just about how prolific this tool really is, it was actually released in July of 1996, which is quite a long time ago. So who knows the importance of, if you were born in 1996, what that means about you today? Real quick, any thoughts? That's right, you can drink. And tonight at Data Night Out, I encourage you all to get Task Manager a glass of my favorite single malt scotch and see if it enjoys it. Moving on, so we're going to go another step up. Again, this is a Windows-provided tool on all machines, Perfmon. Many of you may be familiar with it, maybe not. Again, here, the recording you see is it's a simple view. I have in red the CPU on my system, and in blue the available memory. Again, while starting Tableau Server. There are actually hundreds of metrics here. So here, for simplicity, I decided to show roughly the same behavior and only CPU and memory. But there are hundreds of metrics. You can look at IOPS on disk. You can look at available memory. You can look at network speed. You can even break down CPU utilization by process or processor. All of that is at your fingertips. You can even change the sample rate so you could have this running in the background indefinitely and not use up all your disk space. This is then also easy to share. You can output the file and send it to support when you're working with them on a case. You can refer back to it for all of time. It's really nice. Unlike Task Manager, it was released only back in November of 2006, so it's only 10 or 11, so we're going to send it to our favorite school, Tableau Elementary. Moving along, so we have Tabmon. So now we're entering the tools that we at Tableau created specifically for Tableau and specifically for you to interact with and see what's happening on your system. And one disclaimer before we go ahead, because I see a few people taking pictures. All the links will be made available because the whole slide deck will be available for you later. So you can grab a picture if you want, or you can get it from the slide deck later. No need to rush about getting it. So Tabmon, again, short for Tableau Monitor, the underlying recorder for the system metrics is actually Perfmon. So you can use all of the settings from Perfmon. You can create any profile you want and have it running. One really nice thing, though, if you have a multi-worker deployment, is that you can have Tabmon running, but have it reaching out to all of your workers and pulling data from there all to a single place. So just for a quick show of hands, who has multiple workers in their environment? And now who would want to have to run Perfmon on all of those machines separately? Exactly. So here it pulls all to one place, and that place it's pulling could be your primary or it could be another machine on your network, so long as it can see it and pull the data. It stores everything into a Postgres table instead of the Perfmon format. And then that way, you can build a viz off of it. And so much so, it's so easy that we actually just provided a viz. So here's a sample output from a Tableau server that was running. We break down the performance of the resource utilization, of each process. And so you can analyze what was happening. So in the bottom left, we have different event types. On the top, we see the CPU utilization of different processes. And when I first saw this viz for the first time, I thought that dark blue looked kind of troubling. in IT, when we see CPU spiking all the time, that's not a great behavior. And it turns out, looking into it, we see that that's backgrounder. And it turns out that that was actually the subscription rate that was going on server. So we could see here that subscriptions were starting all at a fixed time. CPU spiked for a matter of minutes, maybe half an hour, and then would drop back down. And that's really good to see so we don't have queuing going on. And we also see at the top of the visit it goes to about 15% CPU. So it's not too bad. But it's nice that we pull all of this data into Tableau. You can interact with it in an easy way. And it's all at your fingertips. And you can then share it with Tableau, and support is familiar with it. So now moving from the open source world, I wanted to kind of shift gears a little bit into that built-in tool, Tableau Performance Monitor. So this is going to be better more for when your user came to you and said, my workbook is just not performing at the rate I need, or more realistically, our executive loaded this on their iPad or on their desktop and it is not performing to the level that they expected, because those are the cases that really get attention. So here we can essentially, you start the recorder, it's in the help menu on the top of the window, and it begins recording. You can do any interactions you want. You can switch sheets. You can do a dashboard action. You can change a filter. And then when you're done, you simply go back to the same menu you started from. You hit stop, and it outputs a new viz. If you're doing it on desktop, it opens a new window. If you're doing it on server or online, it provides a link that takes you to the next page. Then, of course, you can package up this Gantt chart that's created. You can send it along with your logs to support. You can keep it for yourself. Again, I wanted to show you just a quick screenshot of how it looks. It has 3 panes. In the top pane, we see a Gantt chart of everything that happened during your recording. So you started the recording, and as soon as you start clicking, we save events. We save how long they took. In the middle pane, we sort them by how long each one took, because in a performance investigation, almost always we want to attack what was that longest event. We're not trying to shave down the very short events, but we want to see how long did that query take, how long did the layout take, and see if we can get some savings there. And then even beyond that, you can click. In this case, I've pre-clicked on one of the executed queries. You get the query text down below. So you can see exactly what was being sent to your database, and you can see if there's any optimizations you want to do there, if there's too much complexity, potentially from filters on your workbook. So moving on from this, I want to move to my favorite tool, which I'll actually be stepping out of the slide deck to show you a little bit about, which is doing log analysis with a tool that we call LogShark. So LogShark was created several years ago, and what we do is we take your zipped logs, so be them from tabadmin zip log if you have access to the primary machine, or if you have access to one of the admin views, you can generate a log set there and download it to your local machine. So starting with that, LogShark reads that in, it opens up that archive, and then it starts reading through all the files, and it swims through every log line, and it looks for events, and it knows what's going on because we worked with the people who generated the logs. And it takes all that information out of text format, out of JSON, and puts it into Postgres, just like Tabon. So the benefit here is, now that we have it in Postgres, we have those vizzes. And along with LogShark, we've provided a whole host of vizzes to get you started on your investigation to answering questions. We do encourage, once you've started using those, you can start asking your own questions. There are many fields that we don't even use that you could use to dig even more. So I'm going to pause here really quick and switch screens and show you how some of those outputs look off of a sample server. All right. So the first plugin, and that's what we call the individual segments of LogShark or plugins, is the Apache plugin. And so what this does is we read through the Apache logs, all the HTTP logs that are created on your server, and we look for all sorts of different events. But the ones that we most often hear about as administrators is going to be those viz loads. And they're going to say, it was taking longer, it took longer at the end of the week. There are all sorts of interesting behaviors that they might be talking about. So here, as much logs as you provide, Tableau will aggregate into one table, and you can have a viz to look at. So here I have about 8 days of data from a customer. I've anonymized the data here to share, but of course, all of the workbook names and worksheet names would be fully available to you when you're digging in with your own data. And so I should preface by saying that this customer was running on a single node deployment, and they were very much overusing it. If you look here at their daily usage, they were loading 75,000 views a day. So that's a lot. But the nice side effect of this is it makes for a really good demo for all of you. So first of all, in this log set, about 8 days, they had roughly 380,000 workbook loads in total. And here we can see the breakdown by workbook and which are most popular. And you usually see a pattern roughly like this of kind of an exponential curve, and there's always that one really popular workbook. So here, there's this ACT workbook. I don't know what it is in this case, but we can see that makes up for a third of their viz loads. And later I'm going to touch on optimizing workbook design. And one of the things to think about is you may think that saving a second on a workbook load isn't that big a deal, but if it's being loaded 108,000 times in a week, let's say roughly a week, that's 27 hours of CPU time that you're saving. So a 1 second saving on a little bit more efficient of a query or hiding a column there makes a really big impact. One really cool thing that I found in this data set while exploring it has to actually do with when it was recorded. So it was at the end of September, so it's pretty fresh. But are there any salespeople in the audience? No. Who knows what's special about the end of September? Is the end of Q3. So while exploring their data, I noticed an interesting pattern in this workbook. I can't tell you what the content of it is, I'm not sure, but it certainly looks like it is tied to some salespeople's quota attainment numbers. And we can see as I get closer to the end of the month, the number of loads per day increases. And when I move to another view, you'll actually see that the performance of that workbook actually degrades a little bit as we move later in the week. And so when you're hearing from a customer that behavior, you may need to say, currently it's because there's there's substantially extra load on this data source and this viz, and that next week it will be back to normal. And you can, calm their nerves and make sure that they're happy moving along. So now I'm going to actually switch to another page within this same sheet. So this is the same data. Again, we're looking at workbook loads. In the top right corner, every one of those marks represents a viz load that happened on server. So the x-axis is time, again, roughly that 1 week. And on the y-axis, we see how long that request took. So we do see there's a smattering that took quite a long time and often a lot of timeouts. And that's not unexpected to see a few up there, but the density down here is actually surprisingly dense. There are so many marks here that the number of pixels in the screen can't even show it. So there's, like I was saying, 380,000 marks there. And looking closer, it looks like the average load time was 10 seconds, so actually not too bad. Down here, we see the loads per hour, so it's a little bit more granular compared to that viz I was showing you before. And I'm going to go ahead and highlight that same 201 dashboard again. And it's going to filter down all of the data. And again, we see that as the week went on, the load got worse, or got heavier and heavier on that workbook. And on the Friday of last quarter, when all those salespeople were getting ready, they actually peaked kind of near the end of the workday here at 2 p.m. They had 730 loads compared to their peak just on Monday, so still a busy time, of 215. So just because of the time of the month and even the time of the week, they tripled their load on that workbook, and that's tripling the load on all of the resources that support it. So when they're coming to you, it's interesting to look here and see the story, because only some users are going to reach out to you and tell you about their pain or how well things are going. And you can use it as a guidance, but here you can really see the whole picture and everything that's happening on your server. Now, out of curiosity, has anybody used LogShark before, as it has been released for some time? All right, I'm seeing a couple of hands, which is good. So we had a new release that came out earlier this week just in time for TC, and it has a new feature that, once we're done filtering back all the data, I'll show you. So we created a heat map. So this is actually a viz I really like using, and before we had it, I would have to create it every time in the workbook. So I worked with the team to generate this view. So what we do is, we often heard from customers the complaint, I need all my workbooks to load under so many seconds. So in this viz, if you're dark green, we've said, okay, your viz load took less than 50% of that limit. So if you said 20 seconds, the dark green would be all of your loads in less than 10. And in this case, we set that threshold at 30. So it is configurable for your needs. Then as you enter these different thresholds here, you can see what ratio fell into these different bins. So this can be really useful when you do hear from that one customer, man, my quota attainment workbook was just super slow. Well, then you could come here and see, is that the normal behavior? Is that 1% of the behavior? You can come really answer that question. And just to show, you can totally change relatively quickly. I changed that threshold to 20 seconds. All of the colors update, and everything comes out looking like what we want. However, one thing to keep in mind, that the graph you're seeing on top here is a percent of total. So if you only loaded the workbook twice, you wouldn't be able to tell if that ratio is because it's really bad or one of 2 loads was bad, but the next hour there was 100 loads and caching was more utilized. So if you want to dig in a little bit more, you can come down here and we superimpose this color scheme on that loads per hour viz that we saw earlier. Additionally, if we want, we can filter down to a specific workbook because we're looking at everything on this server right now. So if we go back, I'm just going to pick on that 201 workbook again. We get all of that data, and we see, as we approach the last day, there are more of these red loads that are taking a really long time, but we also see that's happening at a time with really excessive load. And briefly, I'd mentioned that you can do additional diving in, see more data, because these are the visits we're providing you based on our experience helping customers like you. But maybe you want to ask a different question. So I'm just going to quickly jump out of the dashboard to this sheet. So here, I just zoomed in, it's the same data, but maybe we have some reason to think that your different VisQL processes are behaving differently, or different workers have different performance. And in this case, we only have one worker, so I'm going to break it down by VisQL process. So just by typing very quick, searching for viz, I put it on rows, and now we break down to 3 different processes. Each viz getting routed to a different process could take a different amount of time. And we could continue to dig in and then ask, okay, it seems like we're getting a lot more of these slow loads out of process 1, while process 0 and 2 seem better. So based on that, we could then guide our discussion more. If this was workers, especially instead of processes, we could start to ask questions. Is there any differences in the hardware? Could we maybe have a failing disk somewhere that needs attention? So this is a really powerful tool to answer any questions that you come along with. And then out of the Apache, the last one I briefly want to touch on is workbook errors by percentage. So we allow all of our users to publish whatever vizzes they want that serve their needs. But sometimes they don't publish great vizzes, and sometimes their vizzes have errors, or they don't publish the data source correctly with it. And that's taking up a lot of resources on our viz. It could lead to timeouts. So we want to be able to identify the worst offenders. So here by default, we're sorting by percent of workbook loads that threw an error. And in this case, it's interesting where this key viz, it had 100% errors. It's as bad as it gets. But then we look over here, and there was only one load. So someone published it. They probably had an error. They learned their lesson, and they pulled it down, and they're hopefully working on it today. But we can also sort, just very quickly again through all that data, for the most by count. And here we can see this Sol workbook, it has 8% errors. So it's not, per load, it's not super high, but it is worth digging in and trying to work with the owners of this dashboard to see, can we fix what's going on here? Because it's just adding all these errors and adding time on the server that's just not utilized. Next, I'm going to jump into Backgrounder, because many of us have subscriptions that go out and people want to get those on time, or we're extracting data sources, which is always a plus for your viz performance. So here, let me open this guy here. This was a customer that they had many backgrounders. They loved doing background jobs. They have subscriptions. They do tons of extract refreshes. This is a 24-hour snapshot, and they actually did 22,000 events in their backgrounder, which is a lot. And I just want to call out green are successful events, so be it a subscription or a refresh, it worked. The red ones failed for one reason or another. So first of all, we can immediately see there's a number of these red ones, and we want to dig in because you can see they're not trivial in length. Some of these are an hour or two long of lost CPU time. So we were able to reach out to the customer and work with them. Additionally, we saw this dense area here kind of in the early morning. And so down at the bottom, we created for them this average wait time. So this was the time you had to wait after you were scheduled. So let's say your refresh should happen at midnight. Here, how long till you actually started? And so here we can dig in and see they were waiting on average potentially more than an hour super early in the morning. And so we worked with them first to get rid of their failing extracts, figure out what was happening there. But then also they chose to get a little bit more breathing room and added some backgrounder processes, and that really helped clear this out. The last example I'm going to move to here is the Server Resource Manager. So earlier, I had mentioned that Tableau has some self-healing properties where it tries to look at itself and see, is any given process hogging all of the resources? So is it using up all of the CPU for a very long extended period of time? Is it chewing through all of the memory? Because basically, one of your users, in theory, could publish a workbook that sends a query off to your database that just fills your memory, because there's no limit to the data you can start pulling back. So what Tableau does, if you trigger one of these thresholds, is it kills the process. Most often, the VisQL server process, or the process that's actually rendering the viz. And one thing I want to say, we're not killing server, you don't get a server down situation, but the individual process gets killed. Anyone who is actively loading a viz does get an error, but besides that, all other traffic is simply routed to the other processes, and then in a matter of maybe 10 to 20 seconds, that process is back and new traffic is coming to it, but all of the memory and resources are released. So this is a very nice self-healing thing. If it happens once or twice here and there, it's not of concern. But again, we've jumped back to that customer with 70,000 loads a day on one worker. They're seeing these happen pretty regularly, where they're exceeding the global threshold or they're exceeding the per process threshold. So this is here, and you can come and see, is it happening often? If so, is your server too full? Are there too many users? Is there a workbook that is using up all of the resources when it's trying to load? You can use this to see that information, while before, you'd have to go look for DMP files in your logs and then correlate their timestamps, which was doable, especially if you like grep, but it's not easy. So we provided this tool that could help you see a little bit about what's going on. I'm going to pause again for one moment and go back to talk about what we can do now that we've seen workbook load issues potentially or server-wide issues. So briefly, I just want to touch on the things that are in our diagnosis toolkit, and then we'll move on. So we started with Task Manager for an instantaneous view of what was going on. Then we graduated to perfmon, getting longer traces, going more in depth, seeing about the finer points about what's happening in our system. Then we checked out tabmon, where we saw what's happening at the per process level, what Tableau processes are using which resources. Then we briefly looked at the Tableau Performance Recorder, where we could hone in on a single workbook and see where are we spending time during the loads, how long is it taking, and diving into some of the query text that was being sent. And then finally, we touched on, as I was saying, my favorite tool, LogShark, where we can really dive in and look at all of the events across our entire server. But now that we've discussed all of these, the question that we really want to answer is, what can we do about it? So we have a whole number of knobs at our disposal. Some of them are within Tableau, some of them are within your environment, some of them are within the workbooks. So the knobs that I want to discuss with you are starting with Workbook Design. So as I was saying, with the example, when we have 108,000 loads of a workbook in a week, we want to make sure that that thing is as optimal as possible. Also, when you have a workbook that your executive team is loading on their iPads, we want that to be pretty optimal too, even if there are only a few people looking at it. I want to touch on database design for those of you who are preferentially using live data connections. And then also, I want to talk about using and optimizing extracts for those of you who are utilizing Background and getting all of your data local. I also want to talk briefly on modifying your Tableau topology. So this has to do with where are you putting your workers, what processes are going where. I'm going to touch on a very important topic, VM settings and resource allocation. Then finally, I'm going to briefly touch on antivirus and security software that we all end up having because we work in corporate environments with IT policies. And then at the end, I'm going to touch on planning for growth. So workbook design. This is a really deep and rich field. There's many things you can do here. So I'm going to touch on just a few things and give a few anecdotes of some things to avoid. And then I'm going to refer you to kind of a document and another talk that we have going on. So some quick things you can do if a user comes to you and they have questions about their current workbook. Look at how many filters they have. Immediately, that's a way to see how complex of a question are you sending. Also, are you pulling back everything in the beginning and then filtering it down once it's locally on the server? All of these things can be saved by cutting down just a handful of filters. You want to think about how many marks are useful. So when you're exploring data, say like in some of those LogShark visits I showed you, you want to start at the more unresolved levels where you have the bar charts of loads per day. You don't want to start showing people all 380,000 marks, because then when they load it, they're going to have to load all 380,000 marks, and that might not be their question. Maybe they're just curious if today has more load than yesterday. So you always want to start a little bit less resolved and empower them with a dashboard action or a link to go to another dashboard that has that detail. There's no need to hide the information from them, but you want to make it not the first thing they see. And then I also want to talk about avoiding massive crosstabs, because this has come up on one or two occasions when I've been working with support where somebody pulls all of their data in. They have tens of columns. They have 10,000 rows. And this comes out to hundreds of thousands of marks. And each of these little marks is basically a word. It might be a number, but it's like a string, one word in length. And the thing to think about, if you have hundreds of thousands of these cells, you're not going to be reading them over your coffee in the morning. And as a comparison, the Lord of the Rings trilogy has 480,000 words. So if you're generating that much text when you load your viz, it's not a good starting point because you're not going to look at it. Instead, you could use a small number of filters at the top where you start with nothing selected. Now, let's say as a sales example, you could pick your region and maybe your sales manager, and then hit apply, and only get the rows that you're actually interested in that will actually help you do things with your data. And this way, you're also saving yourself time, and you're reducing the load on your server. Now, as I said, this is a really deep and rich field. There's a lot of work you can do here. So here's a link to a white paper that is written by one of my colleagues, Alan Eldridge, that's really in-depth. It goes into every viz type. It looks at connecting to different data sources. And I think it's a really great resource. And additionally, he's going to be giving a talk twice at TC that goes into his opinion on best practices that I highly encourage you to go to. I'll be giving the times for those at the end of my talk. So stick around if you want to see when that is. Moving on, I want to touch on database design. So here, I'm thinking more of the people who have a live connection going to their data source. And I'm going to use a quick analogy. So this green box, this is your table that you're pulling from. It's all of your data. You have all sorts of rows, all sorts of columns. So first and foremost, you want to index on the key dimensions. You're probably already doing this. You can talk to your friendly neighborhood DBA, get their help, get their advice. Then the other thing we want to consider is we want to reduce the amount of data that Tableau has to pull back and that has to be queried from the database. So the first thing you can do is start cutting down on columns that aren't needed. And I'll use an example of a data source that I use at work that is, in my case, an abstract, but the same theory applies here, where I'm tracking customer bugs that are in development. So this means I'm tracking development cases using one ticketing system, but then I'm also tracking sales and support tickets in another system and joining them. And this leads to hundreds of rows because it includes everything about the case, last updated time, who the case owners are, and useful information that I need to do my job. But then it also includes information like the customer's mailing address or the geo that their sales team works in. And that information I don't need. So I can save time by not having to pull that in, and I can really start honing down less and less information. Another thing you can do is apply data source filters. We're all probably familiar with them. But it's important, if you can, to do it as a data source filter rather than a filter in your workbook. Because if the filter is in your workbook, we have to still pull back all that data and then chop off the parts we care about. So in my case, I only care about open bugs. If your bug is resolved, first of all, excellent, I'm glad to hear that. I have a different viz that tracks my completed work. But so I can shave off even more of my data and reduce the amount of information that I'm querying and then the amount of information that's sent back over the wire. Because remember, in this example, we're going to a live database that hopefully is in the same data center, but may not be. Finally, for high traffic and critical workbooks, again, see 100,000 loads or your executive team, try making a materialized table where you basically have one row of data per mark on your viz. This is going to give them the absolute fastest performance. There'll be no need to do any calculations. It's ready to go. And it's just going to be really fast, really snappy, and it'll still be live data. Now, advancing on from database design, I want to talk about designing and using abstracts. Most people have probably used it, but there's still things we can do with actually to help us out. So first of all, is it localizes your data. As I said, we don't know for sure what data center your data source is in. It may be in the same building, it may not. This pulls it onto Tableau Server, and it keeps it on one of your Tableau Server machines that if you have multiple workers are still in close contact, or if you have one worker, it's all right there. You only keep the data you care about. So again, we applied those filters when we did the abstract. So we're only pulling what we want. That's the only thing Tableau can even ask questions of. Reduces load on your live data source. If you, for example, have processes that are writing to that data source, say your sales information, here you pull it once, say at the beginning of the day, you get that extract on server, and then that data source is free to be used by anybody and not have any performance impact from, hundreds or thousands of users accessing that data. The final thing that's really nice, if you optimize your abstract, what Tableau will do for you is materialize your calc. So what do I mean by this? If you have some complex calculation based on those columns that you have in there, when you load the viz, Tableau has to go, it has to run all of those calcs on every row and then show you that data. But if you materialize them, we actually make your table a little wider. So we go ahead and add a few columns, one column for each calc, where we pre-compute what were the questions and what were their answers. So now when you load the viz, rather than having to do the calculation, all we have to do is query it, and it's right there ready for us to go. Now, I want to do a little bit of a side, because we were talking about abstracts, and everyone went to the keynote, right? Yes? Okay, so we're talking about Hyper. So Hyper is going to be coming in, it's going to be replacing the data engine, which is the thing that generates and serves your abstracts. So I wanted to just touch on a few finer points so you can be aware of them moving forward. So first of all, the abstract creation and the refreshes are faster. So here, we're not having to sort the data due to the way Hyper is written. So when you think about it, if you're pulling in potentially hundreds of thousands or millions of rows, not having to sort it makes a difference. One thing I did want to point out, and this is more targeted at the people who are going to be doing testing. So you're on 10.4, you want to upgrade to 10.5 or even the 10.5 beta, and you want to start doing some load testing, see, well, how much faster is this new hyper thing? So one important thing is that the hyperizing, as we call it, of your extract happens at refresh time. So if you run 10.4 and you upgrade, that immediate instant, you still have TDE files on your server. So if you were to do a load test right away, performance would look similar. Hyper has a TDE parser. It can perform just as well as TDE engine, no problems. But you're not going to be seeing those advantages. However, if you let your subscriptions run at a normal rate, as they refresh, they're not going to be TDE files anymore, then they're going to become hyper files. Additionally, you can download the data source if you want to a local machine, refresh it and publish it, and get the same experience. I just want to make sure for those of you who are doing performance testing that you keep that in mind, that you need to refresh the extract of the vises that you care about most for that testing. And if they're critical workbooks right after the upgrade, go ahead and trigger that refresh just to get the best performance. And then one thing I wanted to call out at the bottom was that materializing calcs doesn't happen in Hyper. But before any of you get disappointed, it's still faster than TDEs with materialized calcs. So we're still in a pretty good place and we're pretty happy. Okay, so let's move on for modifying Tableau topology. And this loosely covers where your machines are, where processes are. So first and very important thing is keep your workers local to one another. Keep them close. Because we're sending information between them. You have your file store that has your extracts or your hyper files. And I actually want to reference this map here I have in the corner. I had a customer case a few years ago. A customer came and they said, our vises aren't performing great, but only kind of randomly and not all the time. We don't know what's up. Sometimes it's great. A minute later, it sucks. So we started looking using Logshark to see what was going on. And I noticed there was basically two-band behavior. There was fast viz loads, cool, they all took a handful of seconds. And then I saw these slower viz loads that were taking closer to 10. And I was trying to see, well, what's different? Why is there a whole band of slow ones that was very cleanly defined? And they had a primary and 3 workers. They were an East Coast-based company. And so I asked them, is anything up with worker 2? Could there be something with the hardware? No, they're all the same. Great. And that's, where is worker 2? Turns out that worker 2 is in the EU. And so they were sending data. So you would request a viz from your East Coast office, and if by chance you got sent to the SQL server in the EU, your request got sent there, then that server had to ping back to the East Coast to get the file store. And you're adding a lot of back and forth time. So keep them local. Usually it's not cases of that extreme. Keep them on the same subnet, keep them in the same data center. Open up your ephemeral ports. This has been an issue in some versions of Tableau where you have a lot of throughput, but actually Windows Server only opens about half of your ports by default. So we have a really great knowledge base article if you just look up Tableau ephemeral ports that walks you through all of the steps and talks you through validating if you followed through correctly. I really recommend this. It helps with throughput. It utilizes all of the bandwidth that you're paying for with your network. The next point, consider isolating backgrounders on their own machine. This is generally a point to think about if you have a one-node deployment, and actually the example I was showing you in Logshark, they had 3 backgrounders on that box that was loading all 75,000 workbooks a day. So when you think about it, if suddenly those 3 backgrounders start chugging away, refreshing an extract, that can really impact your users who are sitting there watching a spinner. So we want to move as much of that load as possible to another offsite environment. By offsite, I do not mean in the EU. Another tip with the VizQL processes, because often people just think more is better. I've got 8 cores, I'll put 8 VizQLs in there. The VizQL processor, which handles the rendering and sending out the queries and hearing back from your database, it's pretty good at multi-threading and using a lot of resources. So you actually want to allot about 4 cores per VizQL process when possible. That's just a rule of thumb that has come up that I recommend thinking about when you're looking at your topology. Another thing I've seen a lot of customers do is adding a ton of cache servers, because we all love cache, right? So we don't have to wait to hear back from the server. It does it right there. But having multiple cache servers doesn't really make a difference. The time it takes to compare hashes and determine, do we have your query already done, takes less than 1/100th of a second. Even with 75,000 loads a day, the chances of having a collision and having to wait in line is low. And if you have to wait 1/100th of a second, I think you'll be okay. However, you may want to put more things in your cache, and that's totally understandable. And there are some settings that you can go and you can dig in and essentially expand how much space you allow in there before we start pushing out old data to leave space for the new. And one thing I'm just curious to hear about here, because I'm calling out hyper that you only need one per machine. Who here has added a TDE process, an extra one to a machine, where you had one and you added two? Right, I see one or two hands. So that was a recommendation we gave out a lot. And I just want to make clear that moving forward, that isn't necessary anymore. Hyper, it's newer, it's more modern. We've seen our experience using TDE. And even one process alone now can take all of the resources it needs to get its job done. Now I want to move on to actually one of the things I'm most passionate about that definitely makes a difference in your performance and is one of the easiest things to do. So I want to talk about VM resource allocation. Who here knows if their Tableau Server deployment is running on a VM of some sort? I think, is there anyone who doesn't have VM on them? Okay, so a couple, but many are on VMs. I'm sorry for this section. But many of you are on VMs, and we really encourage it. But you need to be cognizant of what Tableau is and how it's running and how to allocate the resources to it properly. So remember that we're a latency and compute-heavy application. We're running queries, we're rendering graphics, we're creating databases. It's a lot of work going on. So we need the resources that you've allocated to us to actually be there. In a VM, when you send out a request, you may get stuck in line waiting for CPU time to become available if your VM host is oversubscribed. That's not always the case, but it could definitely be happening, and I've seen it happen on customer deployments. So VMware wrote a really great white paper, and we've collaborated with them on other white papers where we're looking at how much system reservation do you need for latency-sensitive applications? Because we really want to see you all succeed with the investment you put in Tableau. I want to see you get your money's worth, essentially. And really what we want is 100% CPU reservation and memory reservation to get really that full boost. And one thing I do want to point out, because it has led to confusion in the past, when I say 100% reservation, that doesn't mean that Tableau is not letting anyone else do any work. But if there's a line for the CPU to do action items, Tableau gets to cut to the front of that line for the amount of the CPU that you have reserved for it. And it does make a really big difference. And so we've actually done some testing where we took a VM host, we had one VM run a ton of hardware tests, using up all the resources it could. And on the other VM, we installed Tableau Server, and we started perf testing. And we were looking, the measure we were doing was roughly loads per second. And so we wanted to know, how does actually changing the CPU reservation in an environment like that change your performance? So we're going to do a quick multiple choice of what you all thought the pattern was, and then I'll show you what the final results actually were. So we can start with A. Who thinks it's just a linear relationship? So the more CPU reservation, the more transaction per second. Okay, no one. How about B? It's a little bit of an exponential relationship. Okay, I see a few hands. How about C, where essentially you get diminishing returns after a while? And then how about D, where it's constant performance always? So I'm seeing no hands, which is good. Oh, I saw one hand. We all want D to be true. D would be amazing, because then you could put everything on your VMs. Unfortunately, D is not the case. So the real-world results from this test came out and roughly looked like this. So the thing to consider here is when you don't reserve your CPU on a machine where you're fighting for resources against other totally legitimate processes, maybe you have an Exchange server or you have a database running on those other VMs, you're only getting about a third of the throughput you could have been seeing. So think about that. You're maxing out at 1/3 of the potential of what you've paid for. So by reserving more and more CPU, you can actually get more bang for your buck without spending any more bucks, which is a really awesome side effect. So I think considering this when you're working with your IT team, figuring out the reservation scheme is really important. And that's why I had the multiple choice and showing you the answers, because it's really key. Moving on, we're going to move to another kind of corporate policy-based thing that you want to consider is antivirus. So we all work at companies, and we all have corporate policies. And this means that we probably have AV on our machines, and we can't do anything about it. And if you uninstall it, it gets reinstalled within 24 hours automatically. So again, as we're saying before, we're latency sensitive. We want to be fast. Sometimes antivirus or security software can act as a filter driver. We had a customer where we were adding 200 milliseconds, I believe, per viz load, because every time Tableau had to use a standard Windows DLL to read files, we had to wait that 200 milliseconds for the filter driver to verify that, yep, that Windows-provided DLL is still secure. Go ahead and use it. That was adding a whole lot of time. And so you can put in some exclusions both for Tableau and for Windows that make a difference and are going to make your experience much better, but still, ideally, staying within your corporate policy. Also, if you have an active scanner that runs perhaps at random times or during the day, try to move it to one of those low use times. So back in the Viz with LogShark, you could see kind of in the middle of the night, the amount of traffic really dipped. That'd be a great time to run your daily active scan and still stay within your IT policy. So I think this is kind of a huge thing. It makes a difference, but you can still do what is required of you. So now we've talked about a number of tools and a number of changes we can make, but sometimes we just have to plan for growth. If the usage per user on your server continues to grow and grow, or your user base is doubling and tripling, eventually you're going to hit a limit. There's only so many CPU hours in the day. You need to start thinking about growth. So you had a performant cluster. You can do all of these settings, and I always encourage people to try to optimize everything before they start looking at a need to grow. I think you should get every drop out of every dollar you spent with us. But eventually, as Tableau becomes more popular, new divisions come on board, more users per division are joining, this becomes a more integral part of your business process. You want to start thinking about maybe growing your deployment a little bit. And just, I want to say, this is a possibility to consider in the future, especially with, like I was saying, with backgrounders. You know, you start with one machine and it's great. Eventually, maybe you want to move those backgrounders off and really let your customers have a speedy experience. So some of the options we discussed of what we could do, we can tweak our workbook design, and that small changes there can really have a big impact. We can tweak our database design, and in doing that, we can reduce the amount of data that's being returned, get a speedier experience, save on memory. Using and optimizing extracts, same thing, we're localizing the data. We can make it be just the data we need. It can be really fast, including when we're using Hyper. We can modify the Tableau topology to be a little bit smarter about using the resources that we already have. We can have the big wins of optimizing our VM settings, reserving our CPU, reserving the memory, and really getting everything out of it. Then we talked a little bit at the end there about antivirus and how it can affect Tableau performance. And then at the end, we just talked about planning for growth as something that may be coming in your future. So thank you very much. Thank you all for coming. I did want to touch on some related sessions that relate to the content we were talking about today. And I picked, for anything that had a duplicate session, the furthest in the future. Some of these do have repeated sessions, so please check in the app. But the first one is designing efficient workbooks. So that's the one that's going to relate to that white paper that I'd shared. And this is a great primer to go to the talk, see what Alan was talking about, and then have some really great context when you are reading that white paper for your specific needs. On Wednesday and Thursday, we have Server Tools 101 and 102. And this is going to deep dive into a lot of the Tableau created tools, including a couple I didn't have a chance to get to today. And it's by the developers who wrote those tools. So I really encourage, if you're interested in checking out LogShark or Tabmon, go to those sessions and you're going to see a way more in-depth dive than what I was able to do here. And the final one, Stacking the Deck using TabJolt, is by a member of ProServe who uses TabJolt a lot, which is our internal performance testing tool. And it's now been made open source for you to run if you have a QA environment or you want to just test and see how does my server perform if I double the load or if I add 50% more load, because that can help answer what kinds of things are going to be down the road 6 months or a year. So I think that would be very useful. And if you enjoyed this talk and you want to come again or refer it to a friend, I'm going to be presenting again tomorrow, different room, different time. But please refer people. And then my last thing is, please complete the survey that is in your app about the talk here today. It's very useful feedback, and it lets me know how to improve this talk for the future and learn more about what you want to hear about. So again, thank you all for coming.